All right, greetings everyone. My name is Akarsha. I'm from the Department of ISE, and today's topic that I have chosen is the waterfall model, which is part of your SDLC, which is your software development life cycle. What do you mean by a software development life cycle? These are nothing but phases that we have recognized which allows us to develop a software in a much more structured format. Now, the one that I'm going to talk about, this waterfall model has been introduced by Mr. Vincent W. Royce in the 1970s. It's a linear and sequential. What do you mean by linear and sequential? It means that it goes only in one direction. I will explain in detail in the next few slides what I mean by that, right? But after one phase, sequential means one after the other, linear means in one direction, right? So it's a linear and sequential approach which has several phases. Each of these phases will be explained. In my slides now, I'll be talking about what exactly is the waterfall model, what are the different phases, what are the maybe in which aspect can we use this particular model. Right? So again, like it is a structured and a sequential model used for large and complex IT companies. Why large and complex IT projects? I will again explain when I explain the phases in detail. It will be told, and best used when the requirements are stable. What do I mean by requirements are stable? It means that they do not change. There is no feedback given after every phase for there to be any changes. Now, when we think about a waterfall, right, what do we think about? I'm in Karnataka. Whenever we think of waterfalls or something like that, we think mostly of our joke falls, right? When most of us have, at least from Karnataka, we try to see our joke falls. This is how you structure a main. This is how your waterfall looks like, right? Whenever you see a waterfall, what's the most important thing you see, right? One thing is water is flowing down. Now the water that flows down in each of these, in the sense the water starts off right from the beginning, right? Goes through all of the different layers of rocks, goes through different phases. This phase from this rock here, the water from this rock here cannot go back on top, right? The water which comes from this rock comes here, comes to the next one. Simple gravity. Right? The water here cannot be going back. Same kind of a logic is being used in your waterfall model over here. There are different phases in your waterfall model. Your first phase is your requirements definition, system, software and design, implementation and unit testing, integration and system testing, operations and maintenance. I will explain each phase in detail, but one thing very important that you have to know is, just like your waterfall, how the water cannot go back, your software development process cannot go back from here to here again. Your entire process of your first layer, your first phase must be completed. After you have completely completed that one phase, only then you can move on to your next phase. Then you have to completely finish this phase, move on to your next phase, finish this phase, and so on. There is no scope to coming back from your current phase to your previous phases. Yeah, that's why it's called as your waterfall model. Of course, operation and maintenance, as you can see, happens in the last phase, and hence only if there are any extremely important requirements that have to change or something like that, only then it will be going back. Otherwise, all the phases will be coming phase. Now, let's in detail speak about these phases. What do you mean by all of these different phases, right? First phase is your requirements definition. What do you mean by requirements? Requirements are basically anything that you need for the project to be completed or to be done. That's your requirement phase. So in this particular phase, what you will do is you will speak with your clients. You'll have your company managers, you'll have representatives from your company, you'll have the clients also coming in, and you will speak about what are the different requirements that they require for that particular project. So gathering of all of your requirement analyzing what are the different requirements, taking a clarity on it and writing it down in your SRS document, which is nothing but your software requirement specification. Clear? So you'll have your document with what are the different phases you need. Next is your design phase. In your design phase, there are two types of design or two levels of design that's going to happen. First is your high level design. This high level design talks about the architecture, the structure of your project, how is it going to be, right? Next level is going to be your low level design. What does the low level design mean? Low level designs are what are the different modules you're going to use? What are the different components you're going to use? How are they going to be related to each other? How are they going to flow? What is the data that's going to flow between them? All of these things will be in your low level design, right? And again, these two levels of documentation will be given in your software design document. Yeah, your SDD, software design document, your high level and low level design is happening. So now you're done with requirements, you have sat down and you have decided what are the different requirements you need. Next, you have designed your requirements as per my SRS document. These are the designs I need to do, high level and low level. Next, what is it that you can do? Development. This is your implementation part of your this one. So till now you have sat down, you have brainstormed. Now you're going to sit down and code. What are the different languages that are needed for this project? What are the different ways that you can code this particular project? This will be your implementation part of your design, right? Next is testing and deployment. Before you test this, you are going to also be unit testing. When you're doing your development part, you're coding every development part, that one unit, you will test it, whether it works or not. Next, for the next unit, you'll code it and you will test it. Last is your, your fourth phase is going to be your testing and deployment. This is going to be your alpha testing, your beta testing, your different acceptance testing. Is this project that you have worked on, is it actually something which is being asked by your client? Are the requirements which you have given in the beginning, are they being met, right? So different types of testings will be done and you will deploy or you will publish that particular project that you are going to be working on. Clear? Last phase is going to be your maintenance. Whenever we talk about maintenance, it means that a project is already completed and you're going to sit down and you're just going to maintain. Now what does maintenance mean? Three different types of maintenance happen. First, corrective maintenance. When you talk about corrective maintenance, it means that when you are working on that particular project, you have deployed it, maybe there are some errors. May not be big errors, maybe big errors, maybe small errors. You need to correct those errors for your maintenance. Just like a maintenance of a building, when you have completed the building, maybe some door on some room is not working, right? Maybe some floor, there is some pipe which has gone wrong. So you are just going to correct what already exists, right? That's going to be your corrective maintenance. Next is going to be your perfective maintenance. You have a product, it's working well, you're going to try to evolve that product to make it into a better product. Adaptability, product already exists, everything is working fine, but you're trying to adapt it to your whatever new is coming out in the market, whatever are the market trends, trying to adapt it to new products that are going to be coming by. And of course, maintenance will consume almost 60% of your total project effort. So maintenance is a lifelong thing. As long as that project is going on, you will have to keep on maintaining that particular project even after your deployment, right? Now that I'm done with what is your SDLC, what are the different phases of your SDLC, let's just recap a few features that we have of your waterfall model. One, sequential approach. Like I said, it's like a waterfall. Once you finish one phase, you have to complete it fully, move on to the next phase. Finish it fully, move on to your next phase. Two phases will not occur at the same time. right? Document driven, as soon as you start with requirements gathering, since we are not going to be going back to our different phases, it's very important to document each phase in detail. So we spoke about your SRS document, your SDD document. So it's a document driven approach. Quality control is there at each phase. Why? Because it takes a lot of money, takes a lot of effort, and it's not easy to go back to your phase. So each phase must be checked for quality control. Rigorous planning also needs to be there for each of your phases before you start out on anything. Clear? Importance of your waterfall model as compared to any other model. As you can see in this meme here, it is a very well documented process. It is a very well planned process. So what you plan in the beginning of your requirements is what you get product in the end. Yeah? You want to go to Mars, you're building a rocket, you're testing that rocket, you go to Mars. When you do other types of development life cycles, such as your agile or something like that, you think you want to go to Mars, probably you start to build a rocket, then you think, okay, my project is anyway going, I can anyway change any phase as I want, I will then want to go to Uranus, and then you land up on the moon somewhere, right? So importance or the advantages of having this kind of a waterfall model is you're very clear with your requirements right in the beginning. What you want in the start, you get in the end, right? So clearly defined phases are there, clarity, and it is quite simple. Comprehensive documentation, as you document every phase as you go by. Stability in your requirements, as you cannot keep going back, there is a rigorous planning happening, and resource optimization is happening, right? So online banking is one of the examples that you have for your systems. As you can see, this waterfall model is for a very large IT complex. So it covers your customer requirements like your transaction, security, account management. The design always ensures that secure architecture and encryption is there, because the data that you're going to be giving here is very sensitive and confidential as well. So implementation tests, you have dummy transactions that are happening all the time. So the testing always ensures security and performance and compliance of the entire system, right? So again, maintenance is something that keeps on happening. You have updates, patches, new services, all these different things, right? So again, advantages, I have already spoken about the advantages as I spoke about the features. It has your simple and easy to understand, clearly defined phases, milestones, very thorough documentation, and it reinforces good development habits and suitable for smaller projects as well. Again, when you speak about your software development, it completely depends on the project, what type of project you're going to be taking in. There is no such thing as this is the best software development procedure, nothing like that. It will depend on what problem statement you have. Based on that problem statement that you have, you will have to choose which type of model you will be using for your development, right? One of the disadvantages, of course, the same thing which can be an advantages for some of our problem statements can be a disadvantage for others as well. No feedback path for error correction. Error correction happens in the last because we are not involving anyone in your client will not keep coming back after every phase for your feedback. Hard to accommodate the changes later, because once you are done with phase 1, you move on to phase 2, then move on to phase 3, move on to phase 4. If you suddenly now see that in phase 2 there is an error, you'll have to go back, make that change, and again redo phase 3, phase 4. Right? Because it's like a waterfall. Data coming here will go here. If there's a change in the data here, you'll have to change this also. You'll have to change this also. Right? So it is hard to accommodate the changes later on, because it will change the entire path of what you're doing. No overlapping of phases, quite obvious, because we are talking about a sequential development, right? So we cannot overlap two different phases. Testing cannot happen at the same time as implementation here, You have to finish that. Limited flexibility and stakeholder involvement, as we do not take feedback for each and every phase. Late defect detection and a lengthy development cycle. Lengthy development cycle simply because software development itself can be lengthy based on what you're going to be doing. If your requirements are a little bit more complex, of course you will take much more time to complete each phase of whatever you're going to be doing, right? All right, that's all I have for today's topic. Thank you very much. This is Akarsha D P from Department of ISC.